The next section in our transformation unit is section 3.3, rotations. We're on page 117, and underneath part A in that open space, let's write down some big ideas about rotations. A rotation is a transformation that rotates each point in the pre-image. So if we're looking at this diagram, our pre-image is where we start, our image is where we're going. We rotate around a certain point, in this example it's P, point, and it's called the center of rotation. So that's the point we are rotating around, and we rotate by an angle measure of whatever our angle measure is, and that's called the angle of rotation. The big idea is it is a rigid motion. Length and angle measure are preserved. It is not any bigger or any smaller. And a big thing to know is we rotate counterclockwise. And the reason why is, let's look at our quadrants, where we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. We move through our quadrants counterclockwise, which is why we rotate counterclockwise. If you're given a positive angle measure to rotate around, you're moving counterclockwise. Under part B, let's write some important rules for very common rotations. We have 3 common rotations that we'll use, such as 90 degrees, 180, and 270 about the origin. And there are 3 rules we're going to write down, but first we need to know how to read this notation. So if you see in this example right here, we have this notation, and off to the side, I want you guys to write what it represents. The lowercase r represents rotation. The 90 degrees represents your, what we talked about up here, your angle of rotation. And I'm just going to abbreviate that. This O, that is not a 0, that is an O, like the letter O, represents what you're rotating around, which is the center of rotation. In these 3 very common cases, we rotate around the origin. And then this XY is just what are we rotating? Okay, rotate points, this point. And if it's a triangle, it would say triangle, ABC or something. But pause and jot down these 3 common rules of what happens to our coordinates when we rotate 90 degrees, 180 degrees, and 270 degrees. All right, we're going to skip example 1. We're going to go straight to example 2 and put this into practice. Example 2 tells us the vertices of triangle XYZ are, and it lists them out. I've listed them in a column because that helps me see them better. And it asks, what are the vertices if we rotate 180 degrees around the origin of triangle XYZ? So first we need to know our rule for a 180 degree rotation around the origin, which is the XY becomes negative X, negative Y. We truly keep our coordinates in the same position and change their sign. So our X of negative 4, 7, the X prime, so the image of that would be a positive 4, negative 7, if we're changing their signs. And we're going to do that to each coordinate. Our pre-image Y coordinate of 0, 8 becomes 0, negative 8. And our pre-image Z coordinate of 2, negative 1 becomes negative 2, positive 1. Because all we needed to do was change the sign, not change the position of the coordinate. Let's look at example B, where our rotation has changed. It says we're rotating these 270 degrees about the origin of triangle XYZ. So we need to know the rotation rule for a 270 degree rotation about the origin, where XY becomes Y negative X. So we switch their positions and we change the X's sign. So negative 4, 7, if we switch the positions and change the sign of the X, would be 7, positive 4, because this has changed from a negative to a positive. We're going to do that for each one. This 0, 8 would become 8, 0, because we can't actually change the sign of 0. And 2, negative 1 would become negative 1, negative 2, because we would switch the x and the y, and we would change the sign of the x. And that's how we would use that rule. And this, my friends, is all we need to know about rotations.